So for those catching up, we're on 10.7 in the packet. We follow the directions for calculator settings, changed our mode to polar. This should be negative 9.4 for Xmin and positive 9.4 for Xmax. So first, change your mode to polar, go to zoom, number 4, and then you're going to go to window and change your Xmin and max, Ymin and max, so that you get these settings. Nothing happens? Really?
Yes.
Because I'm getting a graph.
Wait, what? How do you get a circle? One second.
Are you in radians?
Yeah.
No.
Are you in polar?
I'm in radian, polar. Yeah. And I have the windows like negative 9.4 to 9.4. Look.
Bring your calculator up.
We're not friends.
2, 3, 4.
Yeah.
Like that.
We didn't follow the directions. You're supposed to go to zoom 4, and then you're supposed to go change the window like it said in the packet.
Yeah, change the. Okay, so here. So what does this do? What do you do? So how does that turn into a circle?
It just gives you a better window.
Oh.
Yeah, I have. Back in the day.
Late.
Like it was later.
You put them in the words.
I did? No, it's like negative 6.
Yeah, you put all the numbers in the wrong spot.
Yeah.
That's why it wasn't working.
That's not what. No.
You put the Xmin max in the wrong spots.
Oh! So the theta thingy, you don't mess with that?
No, because all you're changing is the Xmin, Xmax.
Oh.
Okay. If yours looks like a potato, you didn't follow directions.
What?
It should look like a circle.
Yeah, mine should.
If it doesn't look like a circle, go back to where it says, do this to your calculator. Okay? In fact, so that everyone who's catching up to us because they weren't here, this is what your window settings should say. 0, 2 pi. Theta step is 0.1. It really doesn't matter as long as it's small. I think, what is this, pi over 6? Nope. Wasn't pi over 6. Maybe it's pi divided by 24. Yep. Something like that. And then negative 9.4, 9.4, Xmin, Xmax, negative 6.2, 6.2, Ymax. And Ymin. All right? So is everybody seeing circles?
Yes.
So if you were telling someone how to graph the equation R equals A now without using the calculator, what would you say? Because that's the goal. We're using the calculator to figure out what it looks like, but then we got to know what these are actually. Yes?
Whatever the number is like the number outside. So like if it was 2, it would be like just the circle 2, right?
Yes. So whatever this number is, whatever A is, that tells you the radius of the circle centered at the origin. So if R equals 2, you guys see how it's going through 2, 2, 2 on the XY axis, right? So R equals, let's say, 5. 1, 2, 3, 4, 5. That would be the circle, the fifth circle, that's radius of 5 units away. Okay? Yes?
Is there anything with like shifting it like left and right or upside down?
Eventually, but we're getting there. Yep. Are there any questions on this type of equation?
Why'd you mark R equals 5?
I just did an example. So R equals A is just a circle, radius A, centered at origin. And then this is the example I did. If R equals 5, then you just go to the center, the pole, count 5 units away, and there's your circle. Okay? go to the next page. This one you cannot use your calculator on. Okay, so we'll go through this one together. If you ever get an equation that says theta equals something, okay, then what you could do is think about graphing several points where theta is that value. So for instance, if we have pi over 4, and I don't know how to graph that, this is what they mean. Like, well, why don't we graph 1 pi over 4, 2 pi over 4, 3 pi, see what that creates. So pi over 4 is which one of these? The second one here. And if I go 1 out, or 2 out, or 3 out, what are we going to get? A line. So this would be the graph. So this is theta equals pi over 4.
So you just do it's just the angle.
Yeah, but you color the entire ray, the entire line. Good. So if we had like theta equals pi, what would my graph be if it was theta equals pi? Which is the x-axis. Does that make sense? Pretty easy, right? Okay. Back to the calculators now. Oh, I guess I should write the description. It's a line through theta equals whatever angle it says. Okay. Okay. Take another minute or two. Here we're looking at r equals a number, 2 cosine theta, 3 cosine theta, 5 cosine, whatever. See if you can figure out how to explain to someone how to graph it without using a calculator once you've seen the pattern. There are 2 options. A could be positive or A could be negative. Okay?
When it's cosine?
When it's cosine, yeah. So we're talking about 2 cosine theta, negative 3 cosine theta. What's going to happen?
Isn't it like the same thing? It's just like, so like if you had r equals 2, which is like what's there, and then you have r equals negative 2.
Let's see.
Like the what's on, yeah, so like if you had 2 and then negative 2, I have 5 and 2. Where's the theta button?
It's the X button.
Oh,
It's got a theta on there.
wait, what's the 5? Wait, Mr. T.
Yep.
Theta number?
Theta is your variable. It's an angle.
How does it work? It does.
How does it know? Because we're in polar mode. When we're in function mode, the variable is x. When we're in parametric, the variable is t, right? When we're in polar, it knows that if you press the variable key, it knows to use theta.
Wait.
Anybody have it yet?
You just have to go out how many numbers it is. Like A. You just go off that nice.
Hold on. Oh, yeah. Not quite the Kevin look, but...
It's impossible to get that unless you
say that again, Ashley? So if I wanted to graph, let's say 6 cosine theta, before I graph it, tell me what it's going to look like.
You go out 6
From where?
from the origin.
So from the origin, I go out 6, 2, 3, 4, 5. Okay, and then what?
You make a circle. You connect that one. That origin.
This to this?
Yeah, but in like a half circle. Yeah. Yeah. Make a circle. Yeah.
Make a circle with these. So is this the radius?
I don't know. Diameter.
The diameter. Good. So we're going to get something that looks like that.
Exactly.
Is that what you're talking about? Let's see.
Wait, is the origin? If you go like 2, 3,
1, 2, 3, 4, 5, 6. Looks like a circle. What's the radius?
3.
Good. So the radius is going to be half of A. But I like I really do like the way Ashley said. So this number here, this A, tells you how far out to go from the pole. Okay? And then you just make a circle where those are the diameter.
So sine will move it up and down.
Well, let's figure. Hold on. Let's be. What happens when A is negative?
Goes left.
Okay, so positive cosine is a circle on the right side. You guys saw that, right? If we did R equals, for example, minus 3 cosine theta, this circle would be on the what? On the left side. So I'd go 3 out, 1, 2, 3 to the left, and then you make a circle there with a diameter of 3, or a radius of 1.5. Okay? Questions on that? Okay, and then Patrick,
Yes, sir.
amazing what you can do when you're actually paying attention,
I always pay attention. What you mean? I ain't Kevin.
said, well, so if cosine makes it go right or left, then what do you think is going to happen when we do sine? Up or down. So let's check that out. Confirm, and then write out the rules. How are you guys being more annoying than when the class is full? I just don't understand that. Yes. Just Pike Place.
Do you know how to make that?
That's some Starbucks?
Yeah. Just black, if you're wondering.
Medium? No, but it's black. You said it was. Yeah, it's medium.
Like, okay, nothing in it.
Emily, please save us all. If I asked you, yes.
Emily, it's up to you now.
Yeah. Get in.
It's not hard to say this from Kevin because
All right, Emily. So if I said R equals 4 sine theta, how would I graph that?
You go up 4 from the origin, and then you.
that's your dad.
Yeah, that's your.
That's the diameter.
Yeah.
So
And you,
make a circle.
yeah.
Okay.
We all get A's, she said yes.
She did say this. Erica, how would I do R equals negative 1 sine theta?
The diameter would be 1, and it would be
So here's where I start. You said, what do I do?
It'd be the diameter of the circle would be 1,
So just,
like -1.
okay. So you get a tiny little baby circle. Okay. Yes.
Are we gonna have to worry about tangent? Is the tangent normal to?
No.
Okay, so we don't.
No. Just 12 that are in the packet. All right. Cardioid. We're only doing 6 today. Relax. 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 You guys, you need to stop freaking out. This is actually easy stuff. People do real well on this quiz that we're doing. Okay? Typically, yes. This quiz will be Monday. Okay? It's all going to be parametric, polar, graphing, easy stuff. All right. Let's figure out 5. The format. The format for this is a number plus the same number cosine, or a number minus the same number cosine. So see what kind of things you get when you graph, and then I'll pick someone to walk me through without the calculator how you would graph something like R equals 2 plus 2 cosine theta, and R equals 3 minus 3 cosine theta.
I don't know if it's like kind of scary. It looks really
Focus on focus on what some main points are. So if you're describing to me what to graph, you should be able to tell me, like, okay, from the pole you can go this way many, that way this many units.
Well, I did two. Like that's not how one.
Are we gonna talk about cosine times sine?
No.
Is what? Caught on to when I said it looks like it's side. Because like you know the each emoji.
Wait, so are we supposed
Here's a clue for what I'm going to look for. There are 4 main points whenever you see this type of graph that you need to know right away. 4 main points. Where are they going to be? That's what I want to know. Anybody know how you would do this first one here?
to?
Kevin?
2 up, 2 down.
So from the pole, 2 up,
2 down,
2 down,
4 to the right.
1, 2, 3, 4 to the right. How do you know?
Because it's. Wait, you got 4 plus 4. There's 4 up, 4 down, 8. No, I know.
Is it like
They just.
Where's the 4th one?
oh,
It's
at the origin.
it's on the pole. Okay? And it
Oh, it's for me, isn't it?
Yep.
It's my last session of choices.
okay.
I have a question.
Yeah.
So like for 4, how do you?
Yeah, we gotta send to the dean's
You just
when she
learned
sends
it.
it.
Yes. So good. All you guys are saying exactly what you should be saying. Here's how you know that this is what's going to happen. And here's what I'd prefer that you learn. Patrick, pay attention. I don't have to explain things to you 4 times. This first number tells you the up-down movement. When you combine these 2 numbers, that tells you the main movement. What I mean by main is this. We said that if we have a positive cosine, that the graph is on what side?
Right.
The right side. So if I see positive cosine, I'm thinking most of the graph's going to be on the right side, and if I add these 2, that's how I get the 4. And then this first number tells you the other minor axis, kind of, how far away those points would be. Okay? And now the reason that we call this a cardioid is because it's kind of like a heart.
Is that really where they call it?
Yes.
Do we always have to hit the origin?
Yes, you do. Has to hit the origin, or the pole.
Do the points, like, on the top, where it curves, I guess, the 2 curves? they mean-
Here?
No, like left.
Here?
Yeah. Do those mean anything?
Well, as long as you don't flatten them out, I mean, we're not going to focus on how far out that radius is going to be, but you just need to know that it goes a little bit into the left side of the y-axis. Okay? So then if I had... Okay. This one. Let's do this one real quick. Let's see. Austin, how do I graph this one?
Okay, so you got it's not really the y-axis anymore, but we all know what it means. It's 3 up and 3 down.
3 up, 3 down, yes.
Oh, Austin.
And then it's going to be 6
6 which way?
going that way to the left.
To the left. Yes.
Wow, Austin, you learned
Good.
so much when you picked.
Then it concaves in at the origin.
Good. So something like this.
Yeah.
Everybody see how that works? Yes.
You said those combined equal the how much you go up.
Yes.
So you always add.
Always add.
So you always add in between them.
So, I mean, look, it's kind of the same, except it's a different shape. But if we go back to, like, this one, for instance, there is no number, right? It's not, it'd be like 0 plus 4 sine theta. But you're still going out 4 in the positive y direction. Does that make sense? Okay. Question?
So, okay, on the test, what are you looking for from us on this?
This.
Just the points? Or
Yes.
But it has to look like a heart.
Yes. Okay, and it's very important that you know that it does go a little bit in to the first and second quadrants here. Okay? Some people will forget, and then what they'll try to do is like connect them and make them vertical here. Well, it's a cardioid for a reason. I mean, that doesn't look anything like a heart if you do that. And I mean, even this is kind of a stretch, but this looks more like a heart than the one we just did here. Okay? You guys good? Let's do the last one. I think at this point you guys already know what's going to happen. So let's just do some examples. If I have r equals 1 plus sine theta, and let's say r equals 5 minus 5 sine theta. Okay.
Do you ask if there's a 1 in front of sign?
Yes. So if it's not written here, you know there's a 1 there. So you are going to, if you want, you can write it in, but you are going to use that. All right, Allison, how do I graph this first one? What do you think? Help her out, guys.
I got it.
1 to the right.
1 to the right,
To the left.
1 to the left,
One up.
2 down, 2 up.
Just kidding, 2 up.
2 up. How do we know it's 2 up?
This is time.
Positive sign, the main or the long direction is going to be up, right? And then the first number tells you the width of the heart. So something like that. Okay. Alexis, what about this last one here? What do you think? 5 left. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good. But there isn't 10. I heard someone already freaking out. What do you do if there's not enough space? Just go further. How many is this? 1, 2, 3, 4, 5, 6. So 7, 8, 9, 10.
I thought you were being serious for a second.
Good. All right. These are just sketches. All we want to know is what the shapes look like, where the main points are going to be. Okay, and the other pre-calc, they're actually not only interested in that, but how the shape is created, what angles are going to give you this. We don't really care so much at this level. We just want to know shapes, where the main points are, and that's it. Okay? Are there any questions on these first 6? Okay, so then Allison, you're going to tell me how to graph r equals 3 plus 3 sine theta.
You got it.
Okay, so go. Okay, go 3 to the left and 3 to the right.
1, 2, 3. 1, 2, 3. Good.
And then here you go 6 up. And then just do your part.
Just do it. Okay. So you know what to do. Okay. I'll see you guys tomorrow.
Sometimes.